Hi, everyone. So today is Wednesday, November 16. We finished chapter 6, okay? So your exam, exam 3 covers chapter 5 and chapter 6. Today you have a quiz. Okay, everybody? Are you able to see the quiz in Blackboard? Right. Your quiz cover session 6.1 to 6.3. Okay. And then your homework is also due today. But if you haven't finished, try to finish as soon as possible. So I hope you can finish your homework before the exam. And please do the practice exam because tonight our review session. What time? 8 p.m. We will go over the practice exam. Okay, so please try those problems first, and then use the red pen to make corrections. And then tonight we can go over the problems together. All right, so let me put a note here for those of you coming late. So review session tonight. At 8 p.m. TED Live. Okay, I hope everybody either attend the video session or watch the recordings. Okay, and last time I give you the handout. Okay, so did you have this handout? If you don't, come and pick it up. Do you have this handout? No, then come and pick it up. Right. So, oh, sure. Yes. So, if you miss some class, make sure you watch the recording. Okay, so last time we go through this, we went through this handout. And make sure you are able to fill out all of this. Because if you cannot fill it out, then it's very likely you will fail the exam. So this is the basic foundation. You have to memorize this. Is that clear, everybody? I know it's a lot, so I'm trying my best to help you to memorize this. Okay, so what are the tips to memorize this? Okay, the 6 trig identities. What are the tips? Remember the hexagon? Okay, and the diagonals. The way you put the hexagon is the way that you pronounce those 6 trig functions. Sine, cosine, tangent, cotangent, secant, cosecant. Right, everybody? And there are 3 diagonals. What is special about the diagonal? You know the product of the 2 n equals the middle one. Yeah, everybody? So therefore, it takes care of the reciprocal identities. And there are 3 upside down triangles. And okay, so for those 3 upside down triangles, you have the sum of the upper 2 endpoint square is the bottom endpoint square. Okay? Remember those 3 upside down triangles? So that takes care of the Pythagorean identities. Okay, and then for those special angle values, okay, that table. So these will take care of these 6 trig identities. And then for these special angles, this table, I told you how to remember it, right? You use the rule for the sine values. Okay, you use the square root of n over 2. And you plug in n is 0, 1, 2, 3, 4. And then that will help you to take care of these 5 numbers. Do you remember that? And cosine, same numbers, reverse order, right? Cosine, same number, but reverse order. Okay? And tangent, you use sine over cosine. So once you figure out the sine values and cosine values. Then your tangent, you use the sine over cosine to get the tangent. Right, everybody? And how about cotangent? Cotangent, same number but reverse order. So same number as the tangent but reverse order. Right, everybody? And secant. Secant is 1 over cosine. Therefore, look at the cosine row. 1 over 1 is 1. And then this one is reciprocal. This one is reciprocal. 1 over 0 is undefined. So that's how you can get the sine values. Cosecant, same number as the secant but reverse order. This is how we can memorize it. Is that clear, everybody? I know it's a lot, but we have to memorize it. So that's why I'm trying to find a pattern. Okay, use the diagram to help you to memorize. But you gotta remember it, okay? Because if you don't remember it, you may fail the exam, maybe the other course. Okay? Alright, so if you want to get through precalculus, those are the things you need. Alright. Okay, so this will take care of the table, right? And this table, this common angle values, only cover the angle from 0 to pi over 2. What if my angle is in other quadrants? What do? Okay, so 0. This is a unit circle, right? This is 0. This is 90 degree. This is 180 degree. This is 270 degree, right? So if I put them in here, I can put 0. And 90 degree is like pi over 2. 180 degree is like pi. 270 degree is like 3 pi over 2. And 360 degree is like 2 pi. From 0 to pi over 2, this is in quadrant 1. From pi over 2 to pi, that is in quadrant 2. From pi to 3 pi over 2, that is in quadrant 3. And then from 3 pi over 2 to 2 pi, this is in quadrant 4. Yes, everybody? Okay, so if your angle is in quadrant 1, then theta and theta prime are the same. So theta prime equals theta. Theta prime is the reference angle. It's the angle made by the terminal side and the horizontal axis. Okay? So your theta prime is always between, so the theta prime is always between 0 and pi over 2. Okay? That's why if you have your angle theta in other quadrants, you find the reference angle and then you can use the common angle values. Is that clear, everybody? So, if the angle is in quadrant 2, draw the picture. That's theta. Well then, this is my theta prime. Do you see theta and theta prime? When we add them up, we get 180 degree. Do you see that? So they are supplementary. Yes, everybody? They are supplementary. We add them up, we get 180 degree. So therefore, theta prime is theta. And then here, theta prime is pi minus theta. Quadrant 3. Theta. This is theta. Theta prime. Theta prime is the angle made with the terminal side and the horizontal axis. Do you see theta prime? Is theta subtract the pi. Okay, so theta prime is theta subtract the pi. Okay. Finally, the 4th quadrant. This is theta, and that's theta prime. Do you see theta and theta prime? We add them together. It's the full rotation. The full rotation is 2 pi. So we add them up, we get 2 pi. Then theta prime is 2 pi minus theta. These are the reference angles. Okay, so now, for example, how do you, this is useful for problem 1 in your exam. This problem 1, I want you to find exact answer. No decimal, no calculator. So how do you find it? Okay, let me just make up, how about secant of 7 pi over 4? Okay, first of all, you want to figure out where is 7 pi over 4. So, do you see the denominator is 4, right? So, okay, look at this. Pi over 2. Well, that is like 2 pi over 4, right? And then pi is like 4 pi over 4. Well, 3 pi over 2 is like what? 6 pi over 4. Do you agree? 2 pi is like 8 pi over 4. Now we have 7 pi over 4. Which quadrant it lies in? 4, quadrant 4. So quadrant 4 right here. Then what is the reference angle? See, the reference angle is 2 pi minus theta. So secant is plus or minus secant of the reference angle, which is 2 pi minus theta. Theta is 7 pi over 4. And we know 2 pi is 8 pi over 4 minus 7 pi over 4. That is pi over 4. Okay? Here, plus or minus, you ask. In the fourth quadrant, your secant is positive or negative? The secant is 1 over cosine, right? Cosine in the fourth quadrant is positive. Therefore, you pick the positive. So that equals positive secant pi over 4. Good. See? Secant pi over 4 is square root of 2. Therefore, not here. We get square root of 2. So if you have your angle in other quadrants, find the reference angle. And then plus or minus depends on the trig function in that quadrant is positive or negative. After you get the reference angle, that is the special angle values you have memorized. Then put down the exact answer. Is that clear, everybody? Yes? All right. So similarly to other like trig functions, sine, cosine, tangent, cotangent, and cosecant. Thank you. Okay. So this is how we find the exact answer. And you cannot use your calculator. So you plug in your calculator, yes, square root 2 is 1.4, you get a bunch of decimals, but our goal is to find the exact answer, not decimal. Okay. And then also we need to remember arc length. So if this is theta and this is r and this is the arc length, let's say is s. So arc length s equals theta times r. Okay, that is the arc length. Okay, and then how about area? Area formula, 1/2 theta times r squared. Okay, that is the area formula. You gotta memorize. Yeah, so everybody look at me, don't look at your phone. These are the things you need to remember for the exam 3 next Monday. Okay, I really hope you can do well on exam 3. So let's try our best. Okay, and then next, angular speed. So angular speeds. So if we have a rotations, okay, angular speed, we use the angle divided by the time. Angle, make sure is in radian. If you have degree, then you have to change to radian. Okay? How do we change from degree to radian? If I have 330 degree, how do you change to radian? You know, we want to get rid of the degree, so you want to put the degree down. Pi is how many degree? 180. So yeah, now you get this is like 330 pi over 180. Yeah, maybe the zero we can cancel that. Okay, so that is radian. You use that angle radian over time. You get the units is radian per second. Okay, this is the angular speed. And then how about our speed? Speed V is omega times r. Okay, everybody, r is the radius. So this is how to calculate angular speed and speed. Okay, everybody? All right, so that is chapter 5. Chapter 6, what did we learn? The graph of 6 trig functions. And they are these. It's kind of slow, right? They're these. Oh, okay. So for the for the 17 minutes you missed, make sure to watch the recording. Okay. So these are the things we need. Okay. How do we remember it? It sounds a lot, but let's find the pattern. How do we remember it? Okay. So how do we remember the graph of the 6 trig functions? Sine and cosine. The shape is like wave. You know wave. They're flowing on the water, the ocean. But sine starts with 0. Cosine, what do you guess? Yeah, start with 1. Therefore, the angle value. Okay, so for the angle value, you can group them into like 3 groups. For sine, cosine, secant, cosecant. Our angle values, we want 0. Okay, so angle value 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those 5 numbers are fixed for sine, cosine, secant, cosecant. And these 5 numbers are exactly the, look at the unit circle, the axis, right? X-axis 0, y-axis 90 degrees, and then pi 3 pi over 2. Okay, so those are the 5 numbers. And it's the same for sine, cosine, secant, cosecant. And now you know your sine wave. Start with 0. See? Your sine value. Start with 0. Go up 1, 0, minus 1, and 0. The numbers are actually very easy to remember because the numbers, okay, the numbers are either 0, 1, or minus 1, or undefined. So not hard. 1, minus 1, 0, undefined. Okay? So you know sine. 0, 1, 0, minus 1, 0. Cosine, start with 1. Then you go down. See? Because it's bounded between 1 and minus 1. So you have 1, 0, minus 1, 0, and 1. Okay, everybody? Does that help you to memorize? We want to find the pattern so we can memorize it. Okay. Once you get a graph for sine, cosine, then you can deduce the tangent and cotangent. How do we get tangent? Tangent is sine over cosine. Okay, so for tangent and cotangent, we also use 5 key points. Sorry, the tangent and cotangent, we use different 5 key points. Okay, the tangent, we use like negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. Okay, and the graph of it really like the x cube. You know, x cube is like that. Really, really like x cube. But it has the vertical asymptote. That's why you get, undefined, -1, 0, and 1, and undefined. Okay, everybody? Yes? This is how we memorize the graph of tangent. And cotangent, the angles, okay, the angles we look at is from 0, pi over 4, pi over 2, 3 pi over 4, and pi. Okay, or you can think of, okay, the period for sine, cosine, secant, cosecant, the period is 2 pi, right? But for tangent, the period is pi. Therefore, your interval is gonna be smaller. Okay, see here. What's your interval size? Pi over 2, right, everybody? But here, what's your size? Pi over 4. Same 5 points, but because here your pi is half of this, that's why the gap between the 2 points is half of this, which is pi over 4. Okay? And then similar as the cotangent, the cotangent start with the 0. Okay? And the graph of cotangent. So tangent, increasing function. Cotangent, decreasing function on one period. Okay, everybody? And then secant, cosecant. Secant, cosecant. Well, that's easier. Once you remember the graph of cosine and sine, your secant, cosecant, just flip it over. So you see, the 1 over 1 is 1. So the 1 that you can think about, oh, this is like a mountain. This is a valley. So this point stay there, and then you flip it over. That's why up, down, up, down, up, down. Okay, everybody? So this is how we memorize the graph of the 6 trig functions. Yes? Questions? Okay. And now, in the exam, I will ask you to draw one. So you have like 3 problems. Okay, so this one problem has 3 parts, and you draw 3 different trig functions. So with 6 trig functions, sine, cosine, tangent, cotangent, secant, cosecant, you draw 3 of them. Okay, and what you do, similarly, you have the x column, the theta column, the cotangent theta, one of the trig function column, and then the y value column. So you write down the theta column and the trig function column. Okay, so these 2 columns will be the same as this. Okay, it depends on which trig function you're looking for. And then after you finish this column and this column, you know theta is the angle, the argument. And then you can solve x in terms of theta to figure out the x column. Right, everybody? And then your y value, looking at the cotangent, this trig values, you can find your y values. Last step, plug those on the xy plane, connect them smoothly. Okay, and then draw 2 periods of the graph and tell me what is the period. Any questions about chapter 6? Okay, so if you miss some notes, please watch the recording and ask me. Okay, so today we kind of review and I tell you how to memorize what are the tips to memorize it? Find the patterns. Okay. And tonight's review session at 8 p.m. Okay, so make sure you come or either watch the recording. When you have questions, ask me. Okay, and right. Yes. Okay. So yeah, last time we also talked about the 6.3, right? That problem 6.3 at the end for the inverse trig functions, you don't have to memorize the graph of the inverse trig functions. So I just deduce it when we need it, okay? You know inverse trig functions, they are inverse functions. So you find a one-to-one piece, restrict the domain to a one-to-one piece of the trig function, and then you just flip it over across the line y equals x. Okay, so I never memorize it. When I need it, I just pick a one-to-one piece and then draw the mirror image across the line y equals x to get the inverse trig function. Okay? And the problem in the exam, I won't ask you to draw the graph of the inverse trig functions. The only problem I will ask you to do is kind of like that. Okay? So step 1, you let theta be this angle. Okay, everybody? And this means theta equals cosecant, inverse cosecant of that. That means cosecant of that angle equals 3x over 7. Then draw the triangle. Okay? Cosecant, hypotenuse over opposite. So hypotenuse is 3x. Opposite is 7. Use the Pythagorean theorem to find the remaining side. And then, what are we looking for? We're looking for cotangent theta. Cotangent, adjacent over opposites. Write it down. Okay, everybody? So your exam will have one problem like this. Is that clear, everybody? So I hope you can finish your practice exam before coming to review session tonight. Because I really hope you have the practice, not just me talking about the problems. You need to know whether you can understand it and be able to do it on the exam. Okay? If you get low scores, make more examples to practice. Okay, everybody? Yes. All right. And I know we are fast, but that's how it is. Look at our schedule. We are already behind schedule, okay? So today we'll talk about 7.1. And then we need to talk about 7.2, 3, 7.5, 4, 7.5, and 8.1, 8.2, and 8.8. We might not have the review time, but I will give you a review session, a 2-hour review session, okay? So usually, you know, algebra, college algebra is 3 credit hours. Trigonometry is 3 credit hours, and we are only 4 credit hours. So it's the pace of the course is fast. So you can finish the 2-semester math into 1 semester, then you can go to calculus 1 in the next semester. I know it's fast. I know it's hard. That's why both of us need to work harder. Hold my hands together. We try our best. What do you need from me? How I can help you? Okay, so I hope to give you all the resources you need to prepare for the exams. Okay, so I feel like I'm the cook. I cook those food, but you are still the person to put your own vegetables. Yes. So. Okay. All right. So, okay, finally get to 7.1, fundamental identities. The reciprocal identities, we already know that, right? Sine and what are reciprocal? Sine and cosecant are reciprocal. Cosine and secant are reciprocal. Tangent and cotangent are reciprocal. Good. And then we also know that tangent is sine over cosine. Cotangent is 1 over tangent, therefore reciprocal is cosine over sine. And also, those upside down triangle identities, Sine squared plus cosine squared is 1. Tangent squared plus 1 is secant squared. And 1 plus cotangent squared is cosecant squared. And the cofunction identities. Remember the complementary angles? Sine of pi over 2 minus pi is cosine, right? Those cofunctions of complementary angles. So tangent pi over 2 minus theta is cotangent theta. Do you remember those, everybody? And okay, negative angles identity. This is kind of new. Okay, why? Okay, this is do you remember what's a function? A function tells us that f of minus x is minus f of x. Yeah, do you remember that? How about even function? Even function tells us f of minus x is f of x, right? Give me an example of a function. Like x cubed, yeah, is symmetric with respect to the origin. Do you remember? How about even function? Give me an example. Yeah, x squared. It's symmetric with respect to the y-axis. You see, it's mirror image about the y-axis. Right, everybody? Okay, now sine. What's the graph of sine? See? If you're familiar with the graph of sine, its wave is starts with 0. Tell me, is symmetric with respect to the origin or symmetric with respect to the y-axis? Origin. So this is the a function. Therefore, sine negative theta is negative sine of theta. Okay, everybody? You can put the negative sign in front of the sign. Okay, cosine. What's the graph of cosine? You start with 1, right? Tell me, symmetric with respect to the origin or symmetric with respect to the y-axis? Y-axis. So this is even. Even function means you can forget about the minus sign. Right, everybody? So sine negative theta is cosine theta. Okay? How about tangent? What's the graph of tangent? Like that. Oops. Okay? Is symmetric with respect to the origin or symmetric with respect to the y-axis? Origin. So this is r. Therefore, tangent minus theta is minus tangent theta. Okay, everybody? We find the pattern. Cosecant. Cosecant is what? 1 over sine, yes? When I draw the cosecant, I always need to draw the graph of sine. And then I do flipping. So flip up, down, right? Up, down, up, down. Symmetric with respect to the origin or symmetric with respect to the y-axis? Do you see this guy? If you rotate 180 degrees, is there? If you do symmetric, the mirror image will be here. See? So it's not symmetric with respect to the y-axis. It's symmetric with respect to the origin. Yeah? So therefore, it's odd. Okay? So cosecant negative theta is negative cosecant theta. Secant! Secant is what? What do you see? Symmetric with respect to the y-axis. Therefore, this is even. So secant negative theta is secant theta. Okay, how about cotangent? Well, cotangent decreasing function. It's symmetric with respect to the, you see, origin. So, which is odd. So, cosecant negative theta is negative cosecant. Cotangent negative theta is negative cotangent theta. Is that okay, everybody? So use odd or even function to figure out. Yeah, that's why you gotta be familiar with the trig identities, gotta be familiar with the trig graphs. They are very, very important. You need them in Calculus 1 and Calculus 2 and higher level math classes. Okay, good. Examples. So, given cosine theta equals 5/8 for theta in the 4 quadrants. Find the values of the other 5 trig functions. Okay, so we have did this example before, right? Kind of. We use 2 methods. One method is use the trig identity. The other method is use your cosine is x over r, like your quiz, right? X over r, and then you let x be 5 and you let r be 8, and then you can find the y. Oh, how about let's talk about the quiz. I do finish grading your quiz. Okay, so yeah, this was your quiz solution. By the way, you know you have a quiz tonight, right? Yeah. Okay, so this is the point on the terminal side of the angle in the standard position. Find the exact value of all 6 trig functions. So here, x is -5, y is -12, r is, by the Pythagorean theorem, that is 13. Then sine theta, y over r, so -12 over 13. Cosine, x over r, -5 over 13. Tangent, y over x, so -13 over -5. Negative cancel, you get 12 over 5. Cotangent, reciprocal of tangent, so 5 over 12. Secant, reciprocal of cosine, so -13 over 5. Cosecant, reciprocal of sine, so -13 over 12. Okay, everybody? So that is the first problem of the quiz 1. Second problem. First, we figure out 90-degree right angle. And then that's why the angle B, this triangle, the sum of all angles are 180 degree. Therefore, B is 90 degree minus 54 degree, we get 36 degree. And then, oh, look at this angle. We're looking for A and B, but we know C. How to relate our unknown A and the known value C. This is opposite, and this is hypotenuse. So opposite over hypotenuse is sine of that angle. So A unknown, C we know that's 15. Therefore, you solve for A. A is 15 times sine of 54 degree. When you use your calculator in the exam, make sure you're in the degree mode or the radian mode. Okay, everybody? All right, and then how about B? B is adjacent to the known value hypotenuse. So adjacent over hypotenuse is cosine, and therefore, so for B multiplied by 15, and we get B is about 8.82. So that is the solution. Mistakes. So here, the mistake is, this is the x, this is the y. Therefore, the students switch the x and y, and then you get all of those are wrong. I only take you 1 point off. Okay, so be careful. Your x is the first coordinate. The y is the second coordinate. And here, this is sine, okay? Not tangent. Opposite over hypotenuse is sine. And cosine is b over 15, not 15 over b. Okay. So you gotta be familiar with the formula, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. All those. Okay, and then here, mix the parentheses. The parentheses is your baby. X squared, parentheses minus 5 squared is positive 25. No negative. See, parentheses, so no negative. Your R is always positive. Is that clear, everybody? Your X could be positive or negative, your Y could be positive or negative, but your R is always positive. Okay. And here, mix the minus sign. See? It's in the third quadrant. Okay. And here, switch to X and Y. So be careful. And here, yeah, these two are wrong. And then here, didn't write it down, the answer, right. R, square root of 169, so that's 13. And here, this is correct. When you plug in your calculator, what do you get? I think your calculator won't give you 15/2, right? Okay. So plug in your calculator. And then here, this is positive. This is positive. Okay. And here makes the minus sign. And then here, why do you have this angle? No, we don't have this angle. This angle is not 5 pi over 6. Okay? This angle, so we know the value, this is -5, this is -12. This angle is not a special angle. So you cannot assume it looks like -5 pi over 6. No. Be careful. Okay. And what is that? So if this is A, tell me this is A. Okay, and miss the minus sign. Switch to X and Y, subtract 1 point. Miss the minus sign, subtract 1 point. Okay. Be careful. So whatever inside the trig function is the angle, but your output is a number, not the angle. So don't put the degree there. So 8.8 and 12.1, they are the length of the side. The units might be feet, meters, centimeters, but the unit is never degree. It's not the angle. Okay, everybody? So trig function, your input is an angle. Your output is a number. You can think of this like the length. Okay, everybody? The degree is only for the input, not the output. Right. So the number are correct, but don't put the degree there. It's not the angle. Oh, but inverse trig function. How about inverse trig functions? Your input is a number, a length. Your output will be an angle. Okay, everybody? So trig function, input, angle, output, a number. Your inverse trig function, input a number, output an angle. Okay? Angle is either in degree or radian. Okay. Yes. So right, cosine. This is a number, not angle. So don't put the degree. If you do inverse cosine, add cosine of a number, the theta will be degree. Okay? So but you don't mean this. All right. Okay, so that's the mistakes. Any questions about the mistakes? Okay, let's continue. Oh, I wish I could have more time. You know, 1 or 2 years ago, our pre-calculus is 4 credit hours, but it's actually 5 contact hours. 5 contact hours means you meet the instructor 5 days a week, and each day you meet for 15 minutes. Then we have an extra 15 minutes, and then we can do more examples and go over it slower. Now we're catching up. Okay. So that's why I need your help. Every day, review, do exercise, If you have questions, ask me. Okay, everybody? All right, so here, I would like to use the method, okay? So quadrant 4, right here. And so theta is in quadrant 4. And we know cosine is what? X over R. Yeah? So this is 5 over 8. So we can let X be 5, R be 8. And then, you know, X squared plus Y squared is R squared. Right, everybody? So X squared is 25. Y is the unknown. R squared, what's 8 squared? 64. Okay, Y squared, 64 minus 25, which is 39. Oh, do you see? Y is plus or minus square root of 39. But we should pick plus or minus. Quadrant 4. Quadrant 4, your Y is positive or negative? Negative. See? Your Y is negative. So we pick the negative square root of 39. Yes, everybody? Okay, now tell me what's sine theta? X, Y, R. What over what? Y over R. Y is negative square root of 39. R is 8. Yes, everybody? And so cosine, we know it. Tangent, what's tangent? X, Y, R. What over what? Y over X. Y is negative square root of 39. X is 5. Yes. And cotangent is the reciprocal of tangent. Therefore, reciprocal, okay, 5 over square root of 39. Okay, secant. Secant is the reciprocal of cosine. What's the reciprocal of cosine? 8 over 5. Yes, everybody? And then what's the last one? Cosecant, right? Cosecant is the reciprocal of sine. Therefore, is negative 8 over square root of 39. Yes, everybody? So we have some example like this before. Okay, problem 2. Express the tangent function in terms of the cosine function only. Okay, so I would say sine and cosine is like the basic ones. All the other trig functions you can express in terms of sine and cosine. Okay, everybody? Why? Tangent is what? Sine over cosine, right? Cotangent is what? Cosine over sine. Secant, 1 over cosine. Cosecant, 1 over sine. So you can express all of the other trig functions in terms of sine and cosine. Right, everybody? So tangent is sine over cosine. And then sine, you can express sine in terms of cosine because of what is the trig identities involve sine and cosine? Sine squared cos cosine squared equals 1. Exactly. So therefore, if you want to express sine in terms of cosine, subtract cosine squared on both sides. And then, but when you take square root, you get plus or minus. Yeah, so you get plus or minus square roots of 1 minus cosine square. That's the sine. And then over the cosine. Okay? So in general, all the other trig functions can be deduced from sine, cosine. That's why you know the graph of sine, cosine, and then all the other graphs can be deduced from it. Right, everybody? Okay, continue. Simplify. Simplify means you want to use the trig identities. Okay, so simplify it. And also think about factor. Okay, so simplify it. You want to factor and also use trig identities. Okay, or if you see some other trig functions, okay, so other trig functions expressed in terms of sine and cosine. So this is what simplify means. Okay, here, what can you factor? Sine. What's left in the parentheses? Cosine squared minus 1. Oh, does cosine squared minus 1 look similar to you? So what's the trig identities? Involve sine, cosine? We just saw it, right? Is that sine squared plus cosine squared minus equals 1, right? What's cosine squared minus 1? It's like we subtract 1 on both sides. Yeah, everybody? We subtract 1 on both sides. And then, what do? We subtract sine squared on both sides. So we get cosine squared minus 1 is negative sine squared. Okay, everybody? So, yeah, we play with trig identities. That's why you got familiar with the trig identities so you can play with it. When you see cosine squared minus 1, that looks like the trig identity, sine squared plus cosine squared equals to 1. So then you know, oh, that equals negative sine squared. Can we combine them? How many? What's the power? 3. So this is how we simplify. Factor it as possible. Okay, and then use trig identities. Okay, 4. Rewrite the following in terms of the sine and cosine functions only. What's secant 1 over cosine? Yes, everybody? What is cosecant? 1 over sine. Yes. Okay. And if you see two fractions, you want to combine into a single fraction. Therefore, the common denominator is cosine and sine. And then the first term, what do you do to it? You multiply by sine, top and bottom, right? So you have sine theta. And then the second, you multiply by cosine, right? So that's why when you combine them, you get sine theta plus cosine theta over sine theta cosine theta. Okay, everybody? So if you see two fractions combine into a single one. Okay. Now, next one. Factor the following expression. How do you factor it? Okay. Now we need our formula. How do we factor? A squared minus b squared. How do you factor? A plus b, a minus b. Yes. What's a plus b squared? A squared plus 2ab plus b squared. So, and if you have minus, then you have minus, right? Yes, everybody? And if you have a cubed minus b cubed, what's that? A minus b, yeah? And then degree 2 terms, a squared, ab, and b squared. And if this is minus, then this is plus. Okay? Therefore, this guy will be a plus b. So this is always the same. Yeah, this is always the same. And then this guy is always the opposite. So a squared minus ab plus b squared. So this is how we factor. Okay, everybody? Do you remember those formulas that we talked about before? Yes, yes. If no, then remember it now. Okay, yeah. All right. Okay, now, oh, you see secant squared minus 1. Which formula do we use? Square minus 1. You can think of it like secant squared minus 1 squared, right? So your A is like secant x, your B is like 1. Right, everybody? So we got A plus B. What's A plus B? Secant x plus 1 and secant x minus 1. Yes, everybody? Okay, good. How about next one? So if you're not like quite familiar with this, you can think of this is like a quadratic function. Okay, maybe make a substitution. So maybe let u be tangent x. Well, then this is like 4u squared plus u minus 3. Okay, make a substitution. Then you can see the quadratic function more clear. How do you factor? So factors of 4u squared, you can put 4u and u, right? Factors of -3, they are 1, -3, or -1 and 3. Which one work? What do I put here? What do we put here? +3 or -3? See, this is plus, right? So you want to have +1 here and -3 here. Then that will give you 4u and -3u. So you add them up together, you get u. Yes, everybody? Do you remember factoring? Okay, if you need more practice about factoring, go to the Mobius lessons, and then the first week, there is a factoring lessons, and there are a lot of exercise you can work on. All right, now u is what? Tangent x, so 4 tangent x minus 3, and tangent x plus 1. So this is how we factor it. Okay. Now, how about this guy? Ooh, here, they're both tangent, so we can do the u. But here, this is cotangent, this is cosecant. But if you have cosecant, can you change the cosecant to cotangent? We have a first how do these relate cotangent and cosecant? 1 plus cotangent squared equals to cosecant squared. Exactly. Yes. So if you see quadratic function, but they are different trig function, try to express them in terms of just one trig function. By the way, we want to change the cosecant square to cotangent square instead of changing the cotangent x to the cosecant. Because if you change this, you will need square root. But if you change this, you don't need square root. That's why. Okay, what's the trig identities involving cotangent and cosecant? Cotangent square plus 1 is cosecant square. Therefore, cosecant square is cotangent square plus 1. Okay, so that's why familiar with the trig identities. This is cotangent square plus 1. And then minus cotangent x minus 3. Okay, now combine them. Combine the like terms. What's the constant term? Yes. And by the way, if you are familiar with that, you don't have to change the u to be cotangent. If you are familiar with it, okay, you could put cotangent x, cotangent x. How do you factor the negative 2? Negative 2, positive 1. Exactly. Negative 2, positive 1. Okay? So if you are familiar, if you're okay to recognize this, that's true. This is a quadratic function, then you can factor it. If you cannot recognize it, you think letting you make the quadratic function look nicer, it will help you, then you can do it this way. Okay, good. Simplify. How do we simplify this? Wow. We have different denominators. So let's take the common denominator. So common denominator is 1 plus cosine x times sine x. Right, everybody? The first one, we want to multiply by the sine x and multiply by the sine x, right? So we get sine x times sine x, so sine x squared, yes? Plus, the second factor, we want to multiply by 1 plus cosine x. All right. So sine square plus distribute. Cosine x times 1 is cosine x. Cosine x times cosine x. Cosine square. Okay. So now, what's sine square plus cosine square? 1, yes. So if you are familiar with the trig identities, once you see sine square plus cosine square, you know that is 1. So therefore, oh, do you see? We can cancel them, right? When we cancel them, we get 1 left. What's 1 over sine? Cosecant x. That's why being familiar with the trig identities is very, very important. Once you see sine square plus cosine square, boom, that's 1. When you see 1 plus tangent square, that is 1 plus tangent square, that is secant square. 1 plus cotangent square, cosecant square. Okay, everybody? So please make sure you are familiar with the trig identities. By the way, so who didn't have this handout? So this handout is also on our website. Okay? I hope you can maybe print more copy to anyone. Print more copy to practice and see if you actually memorize them. Okay, everybody? Because we need that. We want to do well on exam 3. This is like basic. Cheers! See you tonight at 8 p.m.